Welcome to the Embedded Frontier podcast, where we explore modern embedded systems development techniques so that you and your team can develop faster, smarter firmware. I'm your host, Jacob Beningo, founder of Beningo Embedded Group, the Embedded Software Academy, and co-founder of the Embedded Online Conference. Well, before we get started, first of all, I want to wish everybody a happy new year. As we start 2026, it's always a good idea to take a moment to take stock of where we are and look at where we are going as an industry as well. And so in today's episode, what we're going to do is talk about what I see to be some of the 2026 industry trends within the embedded systems industry. Now, as many of you know, the embedded systems industry today covers a lot of space, right? We're talking, dozens of industries. We're talking microcontroller-based systems, 8-bit, 16-bit, 32. We're talking FPGA-based systems running bare metal, systems running Linux, systems that are running on real-time operating systems. There's a wide variety of systems and system types that fall within the embedded systems industry. And so obviously we can't cover every single area and niche of the embedded systems industry. And so what I'm going to talk about today is general trends. And I'm going to take a look at the general trends within the industry through the lens of folks who are working on microcontroller-based systems. Now, that doesn't mean that some of what I'm talking about won't apply to a system that is, running embedded Linux or something that is FPGA-based. But just keep that in mind as we talk about some of these industry trends. Okay, so when I take a look at the industry today, and I think about where we're going as an industry, where technology is leading us. Obviously, as embedded systems developers, we're used to working with hardware. We're used to working in low-level registers. Many of us today are starting to work with systems almost as system integrators sometimes. So there's a wide variety there. But the one trend that I see, even from outside of the embedded systems industry, that is going to have a huge effect on us is, of course, AI. Now, I'm not going to turn this into another AI episode, even though AI is heavily influencing the way that we develop embedded systems and the way that the software industry in general works. I do think that there's a couple of important points related to AI that we need to watch here in 2026. The first one is, of course, the idea of using AI-assisted development to help us develop systems. Now, I see AI as being not a replacement tool. It's not going to replace developers, but it's something that can allow us as embedded developers to be much more efficient. I've seen in my own work over 2025 how much more efficient I've been able to be, whether it's doing code reviews, whether it is improving the way that I do testing, improving the number of tests that I have, whether it is understanding the code bases that I'm working with. AI has a lot of different areas that it can potentially be used to help us cover the things that are mundane and that maybe we don't want to work on again, right? Or things that we do repeatedly that we can now automate or leverage AI to automate those things. And so one of the first things, like I mentioned, that I see AI helping us as embedded systems developers this year is, of course, AI-assisted development. Now, instead of thinking directly, first of all, about some of the things that it could be used for, what I actually am going to point out is that the best thing that you could use it for is actually to develop your own tools to help you develop faster, more robust software. Now, what I mean by that is that many times developers will be working, they'll say, oh, I wish I had a tool for this. I wish I had a tool for that. Oh, I have to do this constantly. I wish I had a metrics dashboard. I wish I had this, or whatever it is. I wish I had visualization tools so I could see what's happening with my system. And what often happened was we'd have to go out in the industry and we'd have to say, okay, is there something commercially available I can purchase? Did somebody, out of the goodness of their own heart, develop some open source software that I can use to do what I want? And if the answer to those questions were no, then I'd say, oh man, I'm just going to have to either bite the bullet and write it myself, or more realistically, I'm just going to not be able to have that resource or that tool that I want. And I'm just going to, kind of push through as hard as I can. Well, with AI, whether you're using Claude Code or whatever your favorite AI tool happens to be, we're in an era where very quickly we can leverage AI to create one-off tools to help us develop our software faster. If you need some type of metrics dashboard, you may not be a web developer or understand, Node or Java or any of those types of things, right? But you can use AI. AI knows those tools very well, And you can say, hey, I need to build a tool that does, X, Y, Z. And you can leverage it to create those tools that help you develop faster, that help you keep track of how your system is working. Okay. And so leveraging AI as a tool developer for you to create little tools that help accelerate the way that you develop software, I have found is extraordinarily useful. If you were to look on my development machine, you would find that I have at least 36 different tools that I've developed to help me develop embedded software. I have a whole different set that I use to help me do, I'll say, business-related activities like recording this podcast. I used to spend a day, from morning till evening, a full work day, recording, editing, posting, doing show notes, all that kind of stuff. I have a workflow now that I used AI to develop, and I even use AI that makes this entire process done in less than 30 minutes. Okay. And so, yes, that's a business related, it's a marketing related example there. But at the same time, I have AI tools that I've created that help me develop tests, unit tests for what I'm working on, that help me do code reviews, that help me validate that my code is actually meeting my coding style guidelines, and so on and so forth. And so creating little tools, and sure, you could wrap them in MCP servers or whatever you want to do, or you can just leave them as, Python scripts that you run locally on your machine. But the idea here that using AI to create tools to help assist in your development, I think, is one of the powerful trends that we're going to see here in 2026. Okay. And there's certainly other AI assisted development activities that we can look at. For example, generating documentation. I hate documentation. It's a necessary evil. I want to make sure that we have it. I love to read documentation so I understand what's happening. But actually creating documentation is extraordinarily expensive. Again, leveraging AI to develop that documentation for you, to make it look pretty, to do an initial draft for you, or to take what you've already written and clean it up so it's nice and pretty. Those are all things that we can use AI to do. Analyzing our code base. I can't tell you, and this might be a consultant problem, right? Is in that I work with so many different teams throughout the year reviewing code, trying to understand their current architectures, helping them re-architect their software or develop a new architecture for, platforms that they're working on or whatever it happens to be. I'm often thrown, millions of lines of code that I need to get up to speed on very quickly, right? And you can use tools like Olama to analyze your code, develop diagrams, flows, all that kind of stuff. Very quickly and easily. And so code-based analysis, whether it's pulling metrics, trying to understand the organization of it, it is an extraordinarily powerful tool that you can use. Not to mention, I've seen tools like if you look at GitLab, they're using AI to help you with pull requests. I've seen tools trying to experiment with the ability to actually add tasks into your project management system and then assign in an AI to go and actually, create code that successfully, solves or completes the user story that is written into the software, that is written into your project management software. So there's all kinds of really cool things that we can do to allow AI to assist us in development. Now, my caveat there is that it's assisting us. It's not the main developer. It's not taking over. It's not the senior engineer. You can't trust what it's doing. And so as we look at the trends this year and leveraging AI, don't become AI dependent. All right. Very easily, you can atrophy your own skills by becoming too reliant on a technology that kind of wants to do everything for you, right? And I've seen in many cases what it produces isn't always what you would actually want. And so it makes a lot of sense in many cases to let it draft something, or for you to write the code, have it give feedback, use it for debugging and all of those types of use cases, okay? Another area of AI development is Edge AI. All right, we're looking at Edge AI, TinyML. I'll be honest, in 2025, I didn't hear that much about Edge AI and TinyML. It's been kind of quiet. But I think there's always a quiet before the storm. If you look at some of the processors that are coming out from the silicon vendors, especially in the microcontroller space, they're adding tensor processors. They're adding neuromorphic processors. They're adding stuff that allows you to actually run inferences a lot faster. The power of our microcontrollers are dramatically increasing. I'm talking about compute power. And so I think what we're going to start seeing here in 2026 is a repush towards Edge AI and TinyML usage, okay, to add a lot more edge intelligence to our devices. Now, some of those examples, of course, you can look to the automotive industry, which is, with self-driving vehicles, lots of artificial intelligence is going into those types of vehicles, or self-driving vehicles. But at the same time, you can look at how Edge AI could be used for medical devices, for sensor monitoring, for discovering whether there's maintenance problems with your devices that are deployed out into the field, watching for security issues with your devices, and so on and so forth. Okay, I think that we're going to see all kinds of edge AI applications. And let's be honest, with how inexpensive cameras and compute technology has become, cameras are absolutely everywhere. And so we're going to continue to see examples of where cameras are being used to help make consumers or businesses' lives easier, whether it's smart buildings. I've seen companies where they're using cameras to just detect whether someone walks into a room to control lighting. I've seen it used for detection of where you're looking, to where, if you're looking at television, the television turns on, et cetera, et cetera. So there's all kinds of interesting use cases, but we're finding cameras and edge AI and that intelligence absolutely everywhere. To be completely honest, I think my toothbrush has a microcontroller in there that is some type of AI, feedback in it that can be used. I don't use it because, I know how to brush my teeth. But if you find that that's a useful technology, we're finding it everywhere. Okay. All right. So, like I said, I don't want to belabor the point on AI, but from a perspective of looking at, embedded frontiers, leveraging and accelerating and finding new use cases for AI in the way that we develop embedded systems to make our code more robust, to help us go faster, is extremely important. There are not enough embedded systems developers out there today. Most embedded software developers, I don't want to say most, but there are a lot of, there's a whole group of embedded developers who are moving towards retirement right now, who have already retired or will be retiring in the next several years. And so there is a complete shortage of embedded developers. And allowing us as embedded developers to understand AI and how we can use it in our day-to-day work to help us be more efficient and more productive really will help close that gap on the demand that is needed for embedded developers. It doesn't mean we won't be needed. It means that those of us who love embedded systems, building things, working with electronics and software together, it opens up an opportunity for us to leverage some of these tools, so that our companies, aren't shorthanded, and we don't, the pressures that are put upon us with the complexity of our systems, all the use cases we're trying to fill in a given year, all of those will be a little bit more manageable as you learn about AI technologies. Okay. Now, another interesting trend that I think is good for us to look at this year in 2026 is security. Security is one of those topics that I know a lot of embedded software developers, we just hate it. I don't know why, whether it's because it's complex, whether it's because security is just something that is, I don't know, it's just something that's not interesting to us, or because of the complexity and all the different areas of expertise you have to have in order to really pull together a good solution. But security isn't optional anymore. There are regulations like CRA coming out of Europe that are forcing us to make sure that our devices are secure. And so while I think a lot of us have avoided security in the past, security is now a requirement. It's not optional. And so from the very beginning of our development cycles, we need to start thinking about security. We need to do threat model security analyses. We need to think through, how do we securely boot our systems? How do we set up root of trusts that are hardware based? How do we do firmware updates that are secure? What does our secure lifecycle processes look like? And so I think this year there will be a lot of re-emphasis on the fact that we need to worry about security. And so I wouldn't be surprised if a lot more teams need training for security, or we start to see a lot more articles talking about how you actually go about securing your systems. I know a lot of vendors have security solutions that they're providing, both commercial, some open source, whether you're looking at like RMPSA or tools like from IAR, for example, who was actually just acquired, I think, at the end of last year by Qt. But no matter which direction you go, security is going to be one of those things that is really important in 2026. And so don't let that trend catch you by surprise. Okay. In my Embedded Software Academy, we had a lot of discussions in Q4 about security, all really around the fact that teams are now, they sell into Europe, and because CRA is now, something that they have to meet, they're trying to figure out, okay, how do I actually, follow through and meet CRA as a requirement for my systems? And so, like I said, I've seen a lot of discussions around that, both in my academy and amongst colleagues and customers I work with. Okay, so that's the second trend, security. The third trend that I see for 2026, I'm going to say, is more platform-based engineering. Okay, now platform-based engineering, many of you know that's a topic that in general, I kind of like. I work with a lot of customers who are re-architecting their systems or architecting new products. And when they do that, they're not looking to create a one-off product. They're looking to develop an architecture, to develop software that can be used in multiple products for multiple customers, oftentimes for 5, 10, 15 years into the future, right? And so platform-based engineering, where you're developing an embedded system that is meant to be reused for multiple products and multiple customers, is a trend that I am seeing quite heavily. And it makes sense, right? As embedded systems become more complex, there's more pieces, more use cases needed by our customers. We can't keep recreating all of these things from scratch. Even though as an embedded systems developer, man, there's nothing like having a project where you can start from scratch and you get to write all the code yourself and design the entire system yourself. There's something very rewarding about that. But unfortunately, that doesn't meet the realities of our world or the state of business and just the state of reality. Okay, there are cases where that can be done, but I'm going to be honest, they're fairly rare. If you look at a lot of like the embedded surveys that are out there, you'll find that really, I think it's like 2/3 or 3/4 of systems are all, the attempt is to reuse previous code, previous designs for new products. Okay, and so we're kind of stuck most of the time with what we've already created in the past. But the platform-based engineering here, the idea here is that in order to successfully create a platform that you can build multiple products off of, you have to adopt modern techniques, right? You have to modernize the way that you're developing your software. Now, that modernization for platform engineering, I've seen is beginning at the silicon vendor level. So if you look at the NXPs, the STs, the microchips, they are producing, I've seen over the last 12 months, a lot of them starting to come out with new software stacks, new drivers, new hardware abstraction layers. I've seen them start to provide base platforms that are CMake based, where they are starting to also move away from maybe the Eclipse-based IDEs, and they're starting to standardize on VS Code and even IDE-based development. Right? We don't need necessarily an integrated development environment. Certainly, it can help, but a lot of us, we just work straight out of a terminal. Which is why I like VS Code. I can just open the code and then I can, run my commands through the terminal, all within an integrated development environment. But I'm not necessarily leveraging, typical IDE-based tools to compile and do the work, that I might be working on. And so I'm finding the vendors are providing us more modern tools, better hardware abstraction layers, CMake-based systems. I'm starting to see the, a big trend that I'm seeing is the adoption of Zephyr. Lots of folks struggle with the device tree. I'm starting to see device tree configuration tools available for teams to be able to leverage so that they don't have to write the device tree code themselves. They can actually set up their microcontroller and then, just click a button and generate their DTS files for their projects or for their platform. All right. Even the way that we organize our systems in Git from a platform-based perspective is changing. Many of you have probably heard in previous episodes, I really like West as a tool. I see West as a fantastic tool to allow you to create manifests, especially if you're doing platform-based development, whether you're using Zephyr or not. West can help you manage platform-based engineering and code management extremely easily. And so I see that again as a big trend, a useful tool for folks who are having to develop a platform and write code that's going to be reused for years into the future and potentially reused, like I said, across multiple customers or for different products. On top of that, if you're going to be doing platform engineering, obviously you have to have a very good software architecture. There's a lot of modernization that's going on around software architectures. Just last year, I was involved in a half dozen or more re-architecture projects. There's several that I'm working on this year. And so creating an architecture that is scalable, that is reusable, that's flexible, that leverages modern techniques for architecture, but at the same time, doesn't forget about the low-level hardware and the real-time constraints that we're under. I know a lot of times I'll talk about data dictates design and there is no hardware, only data. And I do believe that. But at the same time, I'm an embedded systems engineer. I design hardware, I design software. I understand that, yes, there are times where we can't fully abstract out maybe our application code, or where in a lot of the embedded systems we're working on, the interactions with software and that hardware are actually critically important. But at the same time, our architecture has to be separated enough so that we can support multiple customers and products without being tightly coupled to the low-level hardware. And so there are trade-offs there that you have to make. And the trend that I am seeing in the embedded systems industry is that move to there is no hardware-only data. And that is because if you're supporting multiple customers and multiple product lines using the same code base, you have to abstract the hardware. That doesn't mean that we don't worry about the real-time requirements. Those are still really important. It's just we separate that into our architecture into a multi-tiered architecture where one worries about the real-time performance and the other worries about maybe the customer-facing features, and those are a little bit more modular and flexible, let's say that, to be able to change out based on what the needs of the system are. Okay. All right. So I see that happening with platform-based engineering. I think auto coding is something that it's been around for a long time, but I think this year the trend is going to be a lot more interest in auto code. Now, certainly you can auto code using AI. Part of the problem with that is that tends to be non-deterministic. But there are a lot of techniques that I've used over the last 15, 20 years of my career where we use configuration tables and auto code based on creating those types of tables. Using AI in conjunction with platform-based engineering, it can just be an amazing, phenomenal tool that can really help accelerate you and your team's development. All right. And so I see auto code being really important. Certainly trends with platform engineering. DevOps has been a common trend over the years. I think a lot of us embedded systems teams we've at least set up DevOps. And when I say we've at least set it up, we at least have Git and we can compile automatically in our pipelines. All right. Maybe do some basic unit tests. But I do see a wide range there still of teams that are very unsophisticated with their DevOps platforms, and other teams, usually the larger companies, have a pretty sophisticated deployment, whereas maybe smaller teams, again, we either don't have the time or the expertise to really set up DevOps. But again, that's something that I continue to see as a trend within the industry that we can follow. And then maybe one other one here that I'll throw under platform engineering is that I see a continued march for embedded systems developers in adopting C++ as our primary language. That doesn't mean that C is going away. C, I believe, still has something like a 60% market share in systems that are being developed. Part of that is probably because there's so much C legacy code. I'm convinced that I could work for the next 30 years only in the C programming language, and I'd probably be okay. Okay, there's probably I could probably get away with not being an expert in C++ or ever learning Rust. I could be wrong there, okay? But I honestly believe that C++ is the language probably that most embedded systems teams are going to eventually end up using, in the long term, all right? Short term, C is still king. C++ I think is the up and coming language that majority of us will be using for the rest of our careers. Rust, love it as a language, but I see a lot of barriers to it becoming the majority language that is used in embedded systems. Okay, I think it will definitely have its place with its architecture, its memory safety. Just a fantastic language, especially the bug rates that you get using that language. But as a whole, as an industry, I suspect that when I'm retiring at the age of 70 or 75 or something in 30 years, that's when maybe Rust will have the same market share that C++ has today compared to C. So maybe in 30 years, C will be like 20%, C++ will be like 60%, and the rest will be Rust. Okay, that's my thought, anyways. Some of you may have other ideas, and we'll have to see over the coming years and decades, how this actually shakes out. But I can tell you, when I was, when I was an entry-level engineer, back around 2004, 2005, all the literature said C++ is going to take over the world. It's been 20 years, and C++ has gone from a 3% market share to 23% market share in embedded systems. Maybe as high as 30, we'll say. All right. So after 20 years, it's still not the dominant language. Okay. We change languages very slowly in the embedded systems industry. It's not like we're in web development and mobile apps, which change almost on a yearly basis, right? Okay. So those are some ideas there of platform-based engineering, some of the trends that I am seeing here. A fourth trend that I want to share with you that I see being very major in 2026 is simulation. Now, I'm going to be honest. This may not be a major trend that we see. It's the trend I hope we see. I have found that simulation techniques help me to develop software so much faster. It helps me to develop code that's more robust. Simulation really helps you, and I say kind of modernize your development cycle, but to be honest, like I have colleagues who 20 years ago were doing functional simulation on PCs for their embedded systems. This isn't a new trend. It's not a new technology. But I think it's one that more and more developers are becoming comfortable with using. As they develop software architectures that are more decoupled from their hardware, it opens up the techniques to be able to leverage simulation appropriately. Okay, so some of these things, these trends, they're not necessarily new. They're not new technologies. They're just old techniques that we've never fully adopted and leveraged appropriately in our industry. Now, there's different types of simulation. There's certainly model-based simulation where you can use tools like Simulink, where you can use tools that create state machines and let you actually run the state machines and then auto-generate code. I think those tools, certainly have their place. But the real type of simulation that I'm talking about is functional simulation. This is where we decouple our application code from our hardware, using a nice abstraction layer, and we can actually feed in simulated signals to our application code and test corner cases and strange boundary conditions and verify that our test cases are working appropriately and really testing out our embedded systems. I think AI is helping to enable these types of technologies because where a lot of teams might struggle to build out the tools to do this, suddenly you have an AI assistant that you can say, hey, go build this. Go build a sensor simulator for me that generates signals in these ranges and give me a front end that I can use to maybe create step functions and strange conditions that I can feed into this thing, right? And then suddenly, instead of you having to spend weeks or months developing the tools to help you create simulations and test your software, suddenly now you have an AI assistant that can generate this code for you. And so simulation is suddenly becoming a low-hanging fruit tool and technique for us to leverage in order to build embedded systems faster and more robustly. Most teams I talk to today still spend more time debugging their systems. They typically spend 20 to 40% of their time debugging. And so if you can leverage simulation techniques to cut that time in half, that will easily save you a full month's worth of work every year. And that could be per developer. And so you're talking about saving potentially man years in your development cycle by leveraging simulation techniques, by leveraging AI to help you use those techniques. All right. And so in my mind, these are just extraordinarily powerful trends that I think every developer and team should be looking at. Now, the final trend that I want to talk about today isn't a technology trend. Okay. It's not where the industry is going technologically, how we're developing software or systems. It actually comes down to what I'm starting to see as the actual fifth trend is that I'm seeing embedded system skill sets erode. Okay, our skill sets, we're not creating experts anymore. We're not seeing a lot of Jack Gansels and Jean Labrosses and so on and so forth. All these guys who we learned embedded systems from, over the last 20 years. What I'm actually seeing or starting to see is a culture of copy paste, a culture of superficialness, where we allow AI to tell us the answer to something that we need to know right this second, and then we copy and paste it into our code base, and we solve the problem, but we don't necessarily have the depth or the understanding of why that solves our problem. And so one of the trends that I am trying to kind of encourage you to avoid or keep at the top of your mind is that with AI technologies and the fact that we have a lot of entry-level engineers entering our industry who don't have the deep embedded experience of working through 8-bit microcontrollers, of writing an assembly language, of having to work directly with interrupts, of having to worry about race conditions and all the things that come with, essentially cutting our teeth in the embedded systems industry, right? I'm seeing a lack of depth for a lot of teams. And so what I think we have to be aware of is that, yes, AI is an amazing technology, but we need to use it as an assistant and not as a means to the end. All right. And so what I want to try to encourage folks to do to reverse this trend of this copy paste and skill erosion is to use AI to help direct you in the direction of the thing that you need. But don't just copy and paste and then move on to the next thing. Use AI to help increase the depth of your understanding and the level of your expertise. Okay? One of my biggest fears is that 5 years from now, interviews for embedded systems development is going to become, hey, do you know how to look this up? Or the questions are going to be, can you show me that you can solve this problem with AI, right? Not that, hey, can you show me that you understand how to prevent a priority inversion? Or how do you solve this type of race condition in an embedded system? Why is it that you should protect your tick count increment on a 16-bit or 8-bit microcontroller, right? Why is it that that is a critical section? I'm worried that those types of deep embedded knowledge is actually going to go away. And then when teams do encounter, corner cases or race conditions or problems that are actually true embedded system and firmware problems, they're not going to be able to solve those problems, which then means robustness of systems are going to go down. The cost to develop systems is going to go up. People are going to be late delivering their products. And so don't let AI keep you at a superficial level. Use it as a way to help you think deeper, to identify what it is that you need to go deeper on, right? And so that's kind of my thinking of this last trend. And I've started to see it a little bit with folks in my Embedded Software Academy. I've seen it when I go on a customer sites, either to do training or as I'm doing my consulting work. I'm starting to see this calculator culture within the embedded systems industry. And really what I'm doing is warning you about this trend, and that you should, as a developer and as a team, make sure that, make sure this doesn't become habit. All right. I've seen people who, have tried to use AI for things and they use it for 6 months and then they try to go back and, do something and suddenly they discover, oh, I'm not as proficient at doing this anymore as I used to be. And it's because if you're not using those mental muscles, then you're going to lose your expertise. And so use AI to help accelerate the development, to help automate things that make sense, but don't let it cut through and decrease the expertise and the skill level of your team because you're becoming reliant on this tool or technology. All right. So those are some of my thoughts anyways of where I think the embedded system industry is going in 2026. Lots of really cool things there. Like I said, AI, I think, is the main technology for us to watch. I've seen some teams resist it, which can be good, but at the same time, if you're not learning how to use these tools, you are going to fall behind the competition, whether that's other people when you're trying to get a job or whether it's other businesses who are in your market as well. And so don't forget about security, platform-based engineering in your modernization. I highly encourage you to use simulation technologies. And of course, don't forget, AI is a tool to help you figure out where you need to learn and go deeper. It's not a calculator. Be very careful to protect your embedded system skills. And of course, I'm happy to hear of some of the trends that you're seeing because, again, our industry is so wide. So please feel free, if you're listening to this on YouTube or watching this on YouTube, leave some comments below or feel free to email me, jacob@beningo.com, about some of the trends that you're seeing, even within your team or industries. It's always interesting to see, some of the differences that occur within our industry. So with that in mind, happy coding, and I look forward to talking with you again here in the near future. Happy New Year, and happy coding.